Good people, welcome back to my YouTube channel. This is James Mwani Kimani, a technical consultant in civil engineering, an educator and a content creator. Welcome to my YouTube channel. Subscribe to my YouTube channel, The Structural Mind. Here we go. Look at the building, structural element, the columns, formwork on process.
Imagine constructing a massive skyscraper on soft clay. The building's enormous weight would compress the soil. This causes dangerous settlement. To prevent this, engineers use pile foundations. Before designing any foundation, engineers study the ground beneath the project. Every soil layer has different strength, stiffness, and load-bearing capacity, making soil investigation important. Buildings apply enormous vertical and horizontal forces to their foundations. Dead loads, live loads, wind forces, and seismic forces must all be safely transferred into the ground. Pile foundations are selected whenever shallow foundations cannot safely support the structure due to weak soil, high groundwater, or extremely heavy building loads. Construction begins with accurate site surveying. Engineers use advanced instruments to mark every pile position according to the structural drawings. For board piles, a powerful rotary drilling rig excavates deep cylindrical holes through the soil until the required depth is achieved. In loose or waterlogged soil, engineers stabilize the borehole using casing or bentonite slurry to prevent collapse before concrete is placed. Heavy reinforcement cages are fabricated according to structural drawings. These steel bars provide the tensile strength required to resist structural forces. Concrete is poured through a tremie pipe from the bottom upward, preventing segregation and producing a strong, durable pile. Not every pile is drilled. In many projects, precast concrete or steel piles are driven into the ground using powerful hydraulic hammers until they reach the required bearing capacity. Steel H-piles are widely used for bridges, marine structures, and industrial buildings because of their exceptional strength and ability to penetrate dense ground. Some piles support structures through skin friction, where the surrounding soil grips the pile surface and shares the structural load along its entire length. Depending on the ground conditions, engineers design piles to work through skin friction, end bearing, or a combination of both. Individual piles are connected using reinforced concrete pile caps, allowing multiple piles to act as one strong foundation system. End-bearing piles transfer most of the structural load directly onto solid rock or very dense soil at the pile tip. Structural columns are anchored into the pile cap, creating a continuous load path from the building to the deep foundation. Before construction continues, engineers verify that every pile is free from cracks, voids, or construction defects. The ultimate proof of a pile's strength is the static load test, where hydraulic jacks apply enormous forces while engineers carefully measure settlement. Large buildings rarely rely on a single pile. Instead, several piles work together as a group, sharing the structural load evenly to increase stability and reduce settlement. Groundwater can make deep foundation construction difficult. Engineers use casing, bentonite slurry, or polymer fluids to stabilize the borehole and prevent. Pile caps contain carefully arranged reinforcement bars that distribute loads from the columns evenly to every pile beneath. Every load follows a continuous path, from the roof slabs to the beams, columns, pile cap, piles, and finally into the supporting soil or bedrock. Pile foundations are designed to resist not only static loads but also dynamic forces caused by wind, earthquakes, machinery, and vibrations. Pile foundations are widely used for skyscrapers, bridges, offshore platforms, towers, ports, and structures built on weak or reclaimed land.
Poor workmanship can lead to defects, such as necking, honeycombing, reinforcement misalignment, or contaminated concrete, reducing the pile's capacity.
Strict quality control ensures every pile meets the required design standards before the superstructure is constructed. Once the pile foundation is completed and approved, construction of the superstructure begins with confidence that the building has a strong and reliable base.
Good people, enter your YouTube channel, subscribe my YouTube channel, The Structural Mind. Like, share, comment, leave your comment. I thank you all my viewers, my subscribers. Continue to watch my videos. I say thank you very much.